day and welcome to a Nautel product release webinar. I'm your host, Jeff Welton, and we are going to have some fun today. It's always cool when we get to talk about new toys, and it's almost like having Christmas a little early. So today, rack mount digital analog AM and transmitter. There I am. I'm trying to stutter my way through it already. Fortunately, as with all things, I can find a whole bunch of folks to talk about stuff. And today we have got our head of marketing and product strategy, Mr. John Whyte. John, welcome.
Thanks, Jeff. And I share your excitement. It's one of the favorite things we get to do here is to bring new products to the market to serve our customers.
So in addition to be head of marketing and product strategy, John is also on the senior management team and part of the product council. He's one of the guys that makes the shiny new stuff appear. But nothing happens without the folks that actually create it. And on that note, we've got Brooke McKenzie, one of our engineers. Brooke, welcome.
Thanks, Jeff. Happy to be here.
And Alex Morash, our head of engineering. Alex, welcome.
Thanks, Jeff. Hello, everybody.
And the best part about this webinar is that I don't have to do any of the heavy lifting. Brooke and Alex are going to carry all the hard stuff. John will handle the marketing aspect, and I'll just stand here direct. But I will be paying attention to the question page, which brings me to housekeeping. Okay, there is a question button. If you type anything in there, it will show up on my screen. Well, it will now because I just turned it on. But bring your questions to us. We'll interject and answer them whenever convenient. If it happens to be something that's not really on topic, I will mention it so you know that I saw it. But you know, we'll keep it going as fast as we can. Also, if you're an SBE member, don't forget that Nautel webinars do qualify for half of a recertification credit under Schedule I of the SBE recertification schedule. So whatever you use to keep track of that sort of thing, whether it's a spreadsheet or a tablet or scroll it on a sheet of paper, make sure to note that as well. All right. On that note, I'm going to hand it over to John and just start rolling. So, John, tell us a story.
Sure. Thanks, Jeff. Well, first of all, this is all about extending the NX series family, and I want to thank all broadcasters for the confidence they've shown in this product line over the years. It stretches from 3 kilowatts all the way up to 2 megawatts, and at this point we have over 40 megawatts of NX series deployed worldwide, so thank you. And on that range, 3 kilowatts to 2 megawatts, I'm going to pass things over to Alex Morash because he has lived on both ends of this product series, very deeply involved in our 2 megawatt that was installed in Hungary, and he brought to market fairly early in his career our 3, 5, and 10 kilowatt systems. So Alex, if you want to move to the next slide, and you can talk to us a little bit about what makes an NX so well received in the market.
Thanks, John. Yeah, so we'll have a quick look at the NX architecture here. So basically, it's based on a Class D amplifier that we use for generating the RF carrier that you want to put onto the antenna. And that's what you're looking at on the right-hand side of the schematic. So there's 4 FETs that switch at opposite times from each other to produce that carrier frequency. And the amplifier that we designed for NX has been extremely robust, and we also are able to achieve very high efficiencies with it, achieving up to 98% efficiency, driving up the efficiencies of all the NX transmitters.
And Alex, that's basically the same H-bridge design that we've been using for decades, is it not?
Yes, that's right. The RF drive has changed a little bit. The tuning has changed a little bit, but it's basically the same architecture. And then to produce the, yeah.
I get carried away. Sorry, I'm excited.
Yeah, that's okay. And then to produce the amplitude modulation that we're looking for on the output of the transmitter, we need to be able to dynamically vary the voltage that's being applied to that RF amplifier. So to do this, we use a PWM modulator, which is on the left-hand side of the schematic. And basically what it's doing is taking the 400 volts B plus that we use currently in NX, and reducing it down dynamically to produce the modulation signal that we want to get on air. Now, the modulators that we use in NX are multi-phase modulators, and we use up to 6 phases of modulation, or at least 6 phases of modulation. The NX300 uses 9 phases. And that has 2 advantages. One, as you can see from these images, it allows us to replicate the signal that we're trying to put on the air as closely as possible compared to a single phase modulator. And number 2, you actually get cancellation of the PWM harmonics up to kind of 1 below the number of phases. So we get cancellation up to the 5th harmonic in a 6-phase PDM system. And that allows us to push the corner frequency of our modulator filter out as far as possible, or farther than we would be able to with a single phase modulator, providing kind of maximum bandwidth through the transmitter. Next slide, Jeff. So then in NX, we add to that digital pre-correction, where we're basically looking at a sample of the output of the transmitter and comparing that to the, well, demodulating that and then comparing that signal to the signal that we're trying to put on the air. And we're doing some computations in the exciter to try to make the signal that's going on the air replicate what we're trying to get there as closely as possible. So in these algorithms, we correct for amplitude nonlinearities, we correct for phase nonlinearities, and we correct for frequency response, mainly from the modulator filter, again, to get as much bandwidth through the transmitter as possible. And if we look at the next slide, really what that all means is that we can put a signal on the air that really closely replicates the signal that we're trying to put on the air with minimum distortion added.
Now, by the same token, Alex, and correct me if I'm wrong here, but we've run into, not us, but we've seen situations in the field before where some transmitters, if you have any trough overshoot or basically negative clipping, it can cause issues. And that's less a concern with this design, correct?
Yeah, the exciter actually has in it soft clipper for the negative troughs. So it actually prevents the transmitter from going through 0.
And Tim made a comment in the questions that we're going to buy you a new headset for your birthday too. But all right, moving on. Sorry, I got a little carried away again. John.
That's okay. So this is the new NX Series 1 kilowatt. Why don't you jump ahead to the next slide and we'll just get right into this. So it is the same architecture as the larger NXs, the same AUI, same digital polyphase modulation that we just talked about, same exact front UI that you'll see on the NX 3 through 10, same exciter. But if you jump to the next slide, what we couldn't do is take a 2500 watt module and easily make that work in a 1 kilowatt transmitter. We struggled with this for a while. A lot of different ideas were generated. But to make this work, we've come up with a whole new module. So it's a 250 watt building block, 4 of them in the 1 kilowatt. If you jump ahead, and I'm going to maybe ask Brooke to chime in here a little bit, because Brooke has been fostering this new project all the way through, and I'm sure you've got some comments to make as we move forward here.
Definitely. Thank you, John. Yeah, so this is our brand new 250 watt power module for our low power NX series. It's the exact same topology that Alex was just discussing. So it has both the Class D RF amplifier and the 3-phase PDM modulator integrated into one design with some control and monitoring circuitry as well. We're seeing great efficiency with this new module, upwards of 90%. And as with the rest of our NX modules, there's no frequency dependent parts. So that means that this module works over the entire AM band with no adjustments needed. And something that's a little bit different about this module that you'll notice from the image there Each module actually has its own dedicated 40mm fan mounted to the front. And that's really allowed us to optimize our airflow and cooling of really critical components like the RF MOSFETs.
And Brooke, these modules are hot pluggable, yeah?
Yep, they're hot pluggable. We'll see that a little bit further down the slides, but they're hot pluggable like our standard NX modules. We're still able to remain on air with a single module failure. So they have all the same features that we love about our NX modules already. Yeah, so this next slide is just a top level overview of the block diagram for our NX1. If you're familiar with our NX10, it's very similar. It has 4 modules as well. If we start over at the left-hand side there, we have sort of the main supervision and control section. So that would be our control board, which is the same as our low power NX or 5 and 10 transmitters. And that's what interfaces with the exciter. There's an optional second digital exciter. It interfaces with the local control and the AUI as well. And that's what provides the modulation drive and the RF drive to our 4 250-watt power modules. Something else I'd like to draw our attention to down in the bottom is the power supply section. So we have a 15-volt low voltage power supply, and then we also have a 65-volt switch mode power supply, and that's serving as our B+ voltage. So we've lowered the B+ voltage from 400 volts to 65 volts in this new design, and that feeds the modulators in the power modules. From there, the power modules are series combined, so we're using the same combiner topology that we use in our standard NX products, and then those go into a dual T output matching network, which is also used for harmonic filtering.
And I see the note there about the optional GPS, and I'm assuming that that's for time alignment, like if you're doing single frequency network.
Yeah, it's actually a standard card that we can offer with all of our NX products. It's used for even further frequency and phase accuracy. So it's an optional card that you can add in. We still have the 10 megahertz external input that you can use for synchronizing frequency as well, but this is just an additional option that's available.
Cool.
That's great.
All right. I'm going to dump this back to John. So
yeah,
digital radio.
So this is makes for a great analog 1 kilowatt robust transmitter, but it makes for an amazing digital radio transmitter. It's going to be ideal for MA3 opportunities, and I think there's been many folks that have given thought to MA3. Well, this is finally the great platform for it. If we jump ahead to the next slide, I think Brooke had already mentioned how efficient we were seeing the power module to be. So efficient transmitter, but we can take that even further. Now in a 1 kilowatt, does scraping into extra savings make that much difference? I guess the only thing we know for sure is that power rates only go one direction and they go up. So we include, like our larger transmitters, MDCL is offered free, no additional outboard boxes needed. It's just part of the transmitter. Configure it and turn it on. Go ahead, and I think Brooke is going to talk to us a little bit about the robustness of the design.
Yeah, thanks, John. So this is a schematic of the output network. So it starts at our 4 PAs and then goes on to through the harmonic filter. And what this is really illustrating is that this new NX 1 kilowatt is inheriting the full suite of lightning protection and transient protection devices that the NX series has developed over the years. So starting at the output, we have an adjustable carbon ball gap. We still have a directional coupler, and that's really important because it monitors the reflected power, and it's actually able to shut down the transmitter in less than an RF switching cycle. So it's extremely fast, less than 50 nanoseconds. And that means that our PAs won't switch into that bad load if we see lightning coming in from the output. We have a series resonant high pass section that filters out lower frequencies in the lightning range, a fast spark gap across the first input capacitor bank. And then last but not least, we have our voltage and current measurement at the input to the filter, and that's used as supplementary VSWR protection. So we have our full suite. It's fully equipped with all the lightning protection devices that have been proven in our NX higher power series.
And if I'm not mistaken, back all the way to the left in the PA section, if you pull a PA out hot, there's a mechanism to drop a load across that combiner coil so you're not creating a high voltage there, correct?
Yes, exactly. There's a relay on the backplane that allows sort of the current in the PA to continue circulating, even if you were to pull out or disable a module.
Now, Jeff Wilson had asked, and I'll hit this, it's not technical, it's a housekeeping issue, but for anybody who's looking at five camera images, 4 people in one slide deck that's really small, if you click at the top of your menu, the active cameras button, click the little drop down and click hide everyone, you can actually pick and choose what you're looking at. If it was me, I wouldn't pick me. So we got a question from Dave Ewell. We'll hit that in a moment. But Richard Dobbs had asked, can we get a rack mountable frame for one 250 watt module to use as a standalone? So is there, and this is probably more a question for John Whyte, but is there a future plan for 500 or 250 watt variations?
We're certainly watching that space, so stay tuned. We'll take your question as input.
Alan Jerison's asking where the toroid is, and Alan, that goes just a little bit to the right of the output, but before you ground the coax when it leaves the building. So that's a grounding and lightning protection question, and we'll have a webinar or two on that here or there. All right, moving on.
Yeah, Brooke, I think we've got a couple of slides here. We're just going to do almost a product tour. So if you want to just take us through a little bit of an introduction to the rest of the NX1.
Sounds good. Yeah, so just before I get started, I wanted to start with the fact that we were trying in this design to really bring in all the proven technology from our higher power NX transmitters. But at the same time, we also wanted to make a rack mount low power transmitter that had all the things that people would be looking for in that space. So making sure that it was serviceable, easy to install, easy to use, compact. So you'll see that as we go through the next few slides here. So this is the front image of the transmitter. The unit is actually self-supporting via 8 front panel screws that you can see there on the sides. And we have 2 handles in the front that serve as great contact points for lifting the transmitter in and out of the rack if needed. And then the airflow in this system is front to back. So the air is pulled in through the front there. That's air filter media, 1/4 inch foam, and it's exhausted through the rear of the transmitter. So that front panel grill is really easy to remove. It requires a single tool, a Phillips No. 2 screwdriver, and the off-the-shelf air filter media is easy to source, quick to clean, and easy to remove while the transmitter is still sitting in the rack.
And I know I'd asked this earlier, so I'll ask it again, but there is an indent at the rear where you can grab onto it if you need. So for rear, because obviously you're not going to, my wrists won't pull that thing out from the front. I mean, it's fully loaded. It's what, 65, 70 pounds?
Yeah, 77 pounds, everything in, but there's a tray at the bottom that's removable. That's where that indent is. And that pulls out easily. That takes out a lot of the weight as well. The modules and the power supply are easy to remove. So we can get it down to around 50 pounds with those quick removable components gone. But yes, there is an indent in the back that serves as a good place to place your second hand if you're trying to get this in and out of the rack.
Quick question. Lauren's noticing that the audio is reconnecting a lot. If anybody else is seeing that, just throw a note in the questions and I'll know if we have an audio issue. I don't know if we can do much about it, but also worth noting for those folks that this is being recorded and it will be archived and put up on the website later on our YouTube channel. See a couple of other questions, and folks, I'm not ignoring you, but the answer will be pending. So I know if a question is going to be answered shortly, I'll just ignore or skip on by it. All right, moving on.
Yeah, so as soon as you remove that front air filter grill, this is what you see. So there's our 4 hot swappable 250 watt power modules. We're still able to achieve over 50% nominal output power under a single module failure. And this is something we're still testing, so that's likely a very conservative estimate. But what this really means is that you're able to still service a module while you remain on air. So if the module fails, you can pull that out, still remain on air with your other 3 modules. All fans in the system are replaceable easily. So you can see the fan I'm pointing at right there is mounted to a bracket. So you're able to take that out without actually going inside the transmitter. And then at the bottom there, that's that 65 volt switch mode power supply that we're using for our B+. So it's really easy to access. It's really high grade, so 96% efficient. And it's proven to work really well in our other products. We use the same power supply in BX, and it's from the same series that we use in our GB and NB Lite transmitters as well.
Very cool. And I noticed Vaughn had touched on the question about lower power, although he was looking at lower again. So Vaughn, I'm going to get you to send that to me in an email, because he was going all the way down into the LPAM range, 50 watts and change. So that might be a different project. But all right, carrying on.
Yeah, so moving on to the back of the transmitter, the first thing you can see there on the left is our RF output. So we're using a standard type N output connector. The AC input down there at the bottom is connectorized. It's a C20 connector, and it's the only AC input to the entire unit. It takes single phase 185 to 264 volts AC. And then there on the right side, those are all of our user inputs and outputs. So that's where your audio comes in, your GPIO for standard remote control and monitoring, your network connections, all that is easy to access from the back of the transmitter.
Right. So 2 quick questions. I'm going to hit with Eduardo first. How repairable is this unit in the field? And from the looks of it, I'd say reasonably so, yeah?
Mm-hmm. Yeah, we really tried to make sure things were accessible without having to take the transmitter fully out of the rack. Like I said, you're able to operate with 3 modules. If there is a module failure, you get that 3rd or 4th module repaired. So we were thinking about serviceability and being able to repair things quickly in the field.
Oh, Brian's hitting us with a very specific question. 490 watt day power, 11 watt night power. How low will it go?
So it is we're speccing down to 5% nameplate, so down to 50 watts. That would be to meet regulatory requirements. So that's where this transmitter is landing, and then you can increment the power in 10 watt increments.
So he'd almost, for a situation with 11 watts, you'd almost need a 12 dB attenuator externally. Mm-hmm. Okay. Let's see, what else do we got? I think that's it for this exact. Okay, John wants to know what that means, and this will be a question for Mr. Whyte. J1000 being phased out?
Not at this point, but eventually as customer acceptance ramps up for this new product, then this will probably dominate the sales going forward. But no plans at this point.
Right. Okay. Yeah. And I mean, we do the same with the VX and the VS. It's not that big a challenge to run 2 products simultaneously. What fits best for your solution or for your situation?
Yeah, so moving on here to the right side of the transmitter, this is where our double T matching and harmonic filtering section is. This is actually the only part of the design that is frequency dependent, so it's tuned based on your carrier frequency. However, it is fast to change if you do need to retune if you change frequency. So that's that section. And then we also can see our main dimensions here. So it's 19-inch width and 23 inches deep. So it fits in the majority of standard 19-inch racks.
Very cool. And Ryan had asked if they were frequency adjustable, or do they still require, let me get back to it, frequency specific components. So there's a question, do we have to swap out any parts in the process of changing? Like I see 3 capacitors on that back end board. Or are they, is it just a matter of selecting inductor taps, et cetera?
Depending, I guess, on how far the frequency is from your initial tuned frequency, you would likely have to change out capacitors and switch tap points on your inductors. But the capacitors are quite easy to change. They're not as large, obviously, as our ceramic disc capacitors we use in our higher power NX. So they're a lot smaller, easier to sort of screw onto those terminals on the boards and swap out as needed.
Okay. And James had mentioned the J1000 would go down to 8 watts, talking to the night power again. But the thing to remember too, James, is that the J1000 was never type notified below 100 watts. We always do 10% to 110%. So this one at 5% is actually lower as far as what the FCC is considered allowable. Now, having said that, he does raise the question. Let's see. A lot of stations have night power below 50. Can it be set below 50, or is that a hard limit?
I believe it can be set below 50. Maybe Alex, you could chime in here.
Yeah, you can set it below 50. Like Brooke said, it can be set in 10 watt steps all the way down to 0.
Okay, so you could do 0, 10, 20, and
Right.
then if you needed to, you'd end up picking a number and going with the attenuators. Desi was asking about availability. We'll touch to that at near the end of the session. And let's see, weight and dimensions. Weight we covered, right? 77 pounds?
77 pounds, everything in, and quickly able to get down to around 50 pounds with some of our quickly removable assemblies.
Right, very cool. Okay, Tim did want to know if you could pull 2 modules and run 500 watt full time, and I think the answer to that is no, just based on the combiner topology, correct?
Yeah, not currently. We're not sure exactly how much we'll be able to run with one module removed. We're only speccing right now with one single module, I guess, removed from the system.
And we do have, it is 1 rack unit shorter than the J1000, I know. How tall does that make it? 12 rack units, 13?
12, yeah, 12 rack units tall, so it's 1 rack unit shorter. Yep.
Okay, because that was the one dimension we were missing from this slide. Somebody
I think
mentioned
it's
it.
in the next one.
Oh, there you go.
Yep.
Okay, so well, let's move on then. I'm just trying to keep up with the questions as they come, so we're not doing 85 all at once at the end. Did I double tap? No, I didn't. Okay, so there we go.
Yeah, so this is sort of the last section of the designs. We have our control and supervision section. Like I said earlier, it's using the exact same control board that we use in our NX 5 and 10, and the same digital exciters that we use throughout our entire NX series. And you can see from this image that we actually have the optional redundant exciter installed. And then on the front, you can see our user interface. That's exactly the same screen and button control that we use in our NX 5 and 10, so very familiar for people who have used those transmitters. And then there's that height dimension right there. So 12 rack units or 21 inches in height.
And I know it's going to be mentioned in a bit, but this does use the HTML5 AUI that we're using for the VX and the newer boxes, correct?
Yes, correct. Yeah.
Yeah, so we talked about the weight a little bit, but I'll just share this story. I'm not 21 anymore, and last week I grabbed this unit just to move it a bit and picked it up with the full 77 weight. There's something just about the shape of it and where your hand grabs the back of it. It just seemed natural, and I was actually shocked when I realized that I'd lifted that much weight. Maybe I shouldn't be, but certainly when you remove the extra modules, it's quite manageable.
Yeah, us old people like to take it easy on that. I will be pulling the modules.
Yes, advised. So if you jump to the next piece, we mentioned before, this unit also inherits the AUI that we've been installing in NXs for many years now. You'll actually see this is the HTML version of that AUI. We'll have this running on the floor at NEB next week. And I don't think we've ever seen this much control instrumentation in a 1 kilowatt AM transmitter ever. So we're very proud of that. It also includes a scheduler. The things that you're familiar with in the NX 3, 5, and 10 are all there. And if you want to jump ahead, we'll talk a little bit about some of the supervisory control.
Oh, before you get there, I've got questions.
Okay.
So Tim's asking, oh, I'd never even thought about this. Will the HTML5 interface, let's see, we don't have a software person on, but somebody can take a note. Show safe limits. You remember how like the old AUI, you had green, yellow, and red for as you got further and further away from the happy place? Could we do something like, I know we can, is there a plan to do something like that on an AUI revision here?
Yeah, we don't have that in the AUI at the moment, but we are looking at adding it back in because we know people found that information to be quite valuable.
All right. Let's see. SNMP, yes?
Yes.
Cool. And Livewire, I know we've pulled Livewire support from the VS and VX primarily, although we still do AES 67. Is this going to handle that sort of thing? And that might be a John question because I know we'd addressed some of it earlier.
Well, my understanding is not on first release, but we'll take that under advisement. If that's people are interested in that, we can give some consideration to where we take that further on.
And Vaughn's asking if it'll work into existing diplex or ATU setups. The short answer, if I'm not mistaken, is that you've got a better linearity and bandwidth than the J1000. So if a J1000 worked, this should work quite well, correct?
Yes, I believe so. Yeah, if you're not replacing an existing solid state transmitter, um, because of the nonlinear nature of the Class D amplifier, you can get higher intermodulation products. So you might have to think about more filtering. But
Right.
if you
Now,
are replacing a modern Class D transmitter, it shouldn't be any different.
right. And by the same token, if you're replacing an old tube rig, most of the old tube rigs and some of the solid state ones had loading and tuning controls. So you may need to do some tweaking to match to the 50J0, but you would have had to do that with a J1000 and ND1 or any of our other boxes. All right, John.
Well, actually, I'm going to hand this one over to Brooke.
Yeah, so this has some information that we've discussed a little bit already, but as I said before, we're using the same supervision, so the same controller and same exciters as our typical NX transmitters. This is what provides our RF drive and our audio drive for the 4 power modules. And it's also where we have our audio inputs that you can see up there on the top left corner. So dual AES EBU, analog left and right, and I and Q inputs. We talked about our optional GPS input card, so that's for even further frequency accuracy. And then like our standard NX 5 and 10 and even higher power NX products, we also provide GPIO for standard remote control and monitoring.
And I'll put the plug in for Winford Engineering up in Michigan. They make a really cool, and there are other ones out there, but they make a low profile DB25 to Phoenix terminal breakout for converting that DB connector to something that you can screw down for us old people that can't see really well or just don't want to solder DB connectors. So, there are a lot of options there as well. All right, AOIP.
Yeah, so like many of our other transmitter families, we this is almost becoming table stakes for transmitters now, but we include streaming capability, icecast, outcast to give you extra options for if the main feed goes off air. So,
And if I'm not mistaken, the I'd mentioned AES 67 earlier, but we do handle that kind of support, or yes or no, and I could be wrong on that.
no AES 67 at this point.
Okay, so throw it on the list.
Yes.
Let's see. Before actually, I've got several other questions that have come up, but most of them will hit to the question period at the end. Because I like this picture a lot. We did the same type of airflow modeling with the VX series, and it's proven to be incredibly accurate. Brooke, do you want to talk to that, or would you rather Alex?
Yeah, I can talk to that. Yeah, so what you're seeing here is actually airflow modeling that was done in a program called ANSYS IcePack. And you're seeing the air speeds there on the right. And this is actually a model of our 250 watt power module that we were discussing earlier. And we did a lot of modeling on this, this section in particular. And that's sort of how we were able to optimize what fan we picked and the mechanics of the power module. We actually have 2 air deflectors there in the back. So that we could carefully control the airspeed over the critical components, so the modulator MOSFETs and the RF FETs, making sure that those were as cool as we needed them to be for proper operation.
Excellent. All right, John.
Sure. It's a Nautel. Our company is built for staying around for a long time. Our products are built for staying around for a long time. And so is the support. So what you've expected from Nautel will be there for you for years to come.
Very cool. Okay, and wait, who was it? Was it Billy Mays? But wait, there's more.
And there is more. So with the new 250 watt module in our toolkit, we figured we could build a 2.5 kilowatt that would be a lot more compact than anything else that's on the market today. So this is the new 2.5, and if you want to roll forward, yeah, you can get a sense for it compared to the typical tall rack that's out there today. This is certainly less than half the size. It's also single phase, so that works out very well for many installations. As you can imagine, 250 watt power module, we need 10 of those to build this system. Slightly even higher efficiency, and get a sense for the weight, and with components installed and without components installed. So there you go. Two new families of the NX series. They're compact, they're efficient, they have advanced control, and they're digital.
So I'm going to hit a couple of questions right now just because they're relevant. Alan had asked about, we'd mentioned rating to 110% of 1 kilowatt or 1100 watts out. Is that rated in MA3 mode, or is that analog? And have we got an MA3 rating? And I know it's maybe early days to be asking that question, but there you go.
So yeah, MA3, Brooke, correct me if I'm wrong, but I believe it's 1 kilowatt.
Yes, yeah. Yes, we're stepping up to 1 kilowatt, yeah.
And it's important to note that that's average power. So we're not measuring the carrier power there anymore. It's the average power to the transmitter.
Right. Well, in MA3 mode, you're suppressed carrier, so that makes sense.
There's still a carrier there in MA3 mode. Yeah.
Cool. All right. VSWR limits. Are we still using the 1.5 to 1? And do we have foldback similar to the other NX?
Yeah, it's still 1.5 to 1, and it follows the same foldback and shutback scheme as our standard NX.
Okay, can I get you to describe that for anybody that may not know?
Yeah, so currently if the reflected power reaches, I believe it's 16% of the rated nameplate power, so that's equivalent to operating at nameplate power with 100% modulation and into a 1.5 to 1 VSWR load. That causes immediate shutback. And then if we reach, or if the reflected power exceeds 4% of our nameplate power, so that'd be equivalent to running at nameplate, no modulation into a 1.5 to 1 VSWR load, there's a graceful sort of foldback or power reduction in order to maintain that limit.
Very cool. All right. Moving forward, let's see. Vaughn had mentioned the diplexer question that I'd asked earlier about plug and play. This is specifically talking about a backup for a higher power NX at 25 in this case. So if you had to pull an NX 25 out and switch the NX 1 or 2.5 in as a backup, should be just a straight connection, correct?
Yeah, that's right.
Do you have to adjust for phase rotation or phase shift at all? Phase delay, I guess, was what I was thinking.
Yeah, the phase delay through the filter will be different than the high power NX transmitter. So if that is important to be adjusted, but generally that's only a concern in digital modes of operation.
All right, very cool. I think that brings us pretty close to the end. We do have the online information. As I mentioned earlier, this webinar is being recorded, and you'll be able to get to it through the webinar link on our main website, or just by going directly to our YouTube channel and looking it up there. The NX series product page is live as of about an hour and a half ago, and you can find a spec sheet there. Understand that it is preliminary. Let's see. I'm going to flick forward to the question. I do still have some other questions, so I'm going to hit these as we go. Ryan had asked about price point, and John, I'm going to throw this at you. I was going to say throw you under the bus on this, but either way applies. At this point, it's still fairly preliminary, correct?
I can get prices to you, Jeff, and to our sales team. So, but I will say this. So this is a lot of capability, a lot of equipment. So it will be, compared to a J1000, it's going to be some amount more. The 2.5 makes sense. It's going to be less than what the 3 kilowatt was.
So that's one of them. Definitely talk to your salesperson.
Yes.
Eduardo had asked about sparing 10 minutes for NAB. So Eduardo, shoot me an email, jwelton@nautel.com, and we will absolutely set something up and make sure you're looked after. Ryan had asked, and I asked the same question, Ryan, does it use the same power protection unit as the J1000? Now, anybody who's played with the J1000 knows that we had 2 PAs with 4 MOSFETs each, and they were somewhat susceptible to nastiness coming down the line. Brooke, I'd asked you this during our pregame earlier today, but about MTBF on the device we use in the PA, because it is similar to what we've been similar design to what the NX has been using. Because the only difference, the J1000 surge protector is the one-to-one isolation transformer, and as I understand, we're probably not going to be providing that as an option with the low power NX. Correct?
Yes, I believe that's right. Yeah, we do have MTBF data on our NX module, obviously not in this new version, but it's based very closely on that. And it's over 30 years mean time between failure for our current NX module. So pretty good on that regard.
So the short answer is we can provide an AC line protector. You still should use the good grounding practices that we've been preaching for decades. And in case Alan Jerrison's still listening, yes, I think I'm going to want a ferrite on there somewhere. But beyond that, yeah, we will probably not be including the one-to-one isolation transformer that the J1000 does tend to play a lot happier with. All right, let's see what else I missed. Dummy load connections. So there is a question. This one doesn't need a reject load like the J1000, right? If you pull a power module.
Yep, doesn't need one, no.
Okay, cool. So if you wanted to run it into a dummy load, it's just going to be the same as any other box. It's the same output connector and put a switch on it. Let's see. I think that covered everything. If anybody else has any questions, you've got about 30 seconds while I ramble on meaninglessly, and then we will let everybody have the rest of their day back. But folks, I want to thank you very much for spending some time with us. If you're going to NAB in Las Vegas, by all means, swing by the booth. We will absolutely have that there, and pretty sure we'll be excited to talk about it.
Yeah, all 4 of us will be there to take your questions.
Oddly enough, it's not considered to be a voluntary show. So, Brooke and Alex, thank you very much. John, as always, I thank you for your time. And folks listening and watching at home, again, thank you very much for your time. Have a wonderful day.